Hi everyone, okay, welcome to my video for today. Okay, today I'm going to teach you about how to balance chemical equation, to be exact, redox reaction by using oxidation number. So if you watch this video, of course, you do not need to look at any other videos, okay, because for Cambridge CAIE, okay, this video is enough, yeah, because we are going to explore every single thing that you need to know whenever they say balance the chemical reaction or redox reaction by using oxidation number method. Okay, so without wasting any more time, okay, let's go to our video today. Yeah. Now, if you look at the first equation over here, okay, you can see, okay, I have written an equation. This is going to be involving Fe2 plus, okay, with MnO4 minus, okay, and then you have Mn2 plus, okay, to give you Fe3 plus as well. So let's actually look at, okay, what we are going to do in order to balance this equation. First of all, okay, we are using the oxidation number method. So first, okay, you need to know about the oxidation numbers. How to use the oxidation number and the general guideline and so on, you can watch my previous video that I have done. Okay, I will put some of the videos that I've done in the description, and then you can also see and look into that video. So for now, okay, the oxidation number of Fe2 plus is going to be plus 2. And okay, this is going to be Fe3 plus, so the oxidation number is plus 3. It is important to note that we are dealing with, okay, one atom of one Fe2 plus and one Fe3 plus. So I am going to actually no need to worry so much about this. Okay, we can just say, okay, from plus 2 they are going to change into plus 3. So there is going to be an increase of 1 unit. So I will put increase of 1 unit over there. And then, okay, I am going to look at Mn, yeah. So I'm not going to look at hydrogen ions, okay, because hydrogen ion, as you know, hydrogen ions, okay, hydrogen in compound, okay, and even in ion, they are always going to be plus 1 except for, okay, metal hydrides, okay, but we are not dealing with metal hydrides over here. So I am going to find the oxidation number of Mn over here. Do take note, we are dealing with one atom or one ion of Mn, yeah. So there is no problem over here, okay. Later I'll show you some example that we need to do special consideration. So for now, okay, you can calculate the oxidation number of Mn, okay. You can just put X, okay. Then 4 times negative 2, because oxidation number of oxygen in a compound is going to be always negative 2, equals to the overall charge, which is going to be negative 1. This is a negative 1. So I can calculate X is going to be negative 1. That 4 times negative 2 is negative 8. So I bring it to the right, it's plus 8. So I am going to get plus 7. So I put plus 7 over here. And the oxidation number over here, it will follow the charge, which is going to be 2. And we can see that, okay, there is going to be a change, okay. In this case, it's important to notice as well, okay, there is going to be from, we are dealing with 1 Mn, yeah, as I mentioned to you earlier. So this is going to be, okay, 7 to become 2, so there is a decrease by 5 units, okay. So there is going to be decreased by 5 units. I'll put negative 5 over there. So the next step is to make sure the decrease and increase using this oxidation number method. We need to make sure that we get the same ratio. So when, let's say, there is going to be a decrease of negative 5, okay, negative 5 change, then we are expecting to have positive 5. In this case, we have positive 1. So we need to make it as the same ratio. So what I'm going to do, I'm going to times this by 5. So I am going to get positive 5. And in this case, this one just times by 1. So I'm going to have negative 5 and positive 5. Now, the number that I have circled over here, this one, I'm going to call it as magic numbers. And we will actually use this magic number. You can see number 5 that I put over there. This number 5, okay, will be actually written over here. You just put number 5 over here. And if you have 5, yeah, in this case, this example, no need to worry so much. If you put 5 over there, because we are dealing with one atom or one ion of Fe2 plus, automatically this will become 5 as well. Why? Because, okay, there is only going to be on the left, if you have 5, on the right, yeah, there is only Fe is given on the right, and it must be 5 as well. So I just put 5 over there. Now, the first magic number is settled, and let's look at the second magic number. Now, for the second magic number, you can see it's going to be 1. Okay, so if I put 1 over here, okay, and I'm very sure this is going to become 1 because this is, we are dealing with 1 ion of Mn, okay, or 1 atom of Mn, 1 element, yeah. So this is going to be 1. The last thing that you need to go into settle is going to be related to oxygen. And you can see here, since this is a magic number, this number will not change, okay? It will not change. You do not go and disturb this number. So in this case, if I don't disturb this number, okay, the number of oxygen atom, okay, on the right, left-hand side is going to be always 4. So what I need to do, okay, I can actually just put this 4 over here because, okay, if I put 4, then only I'm going to have 4 oxygen here. So once I have the 4 oxygen, now I can actually look at the number of hydrogen atom, okay, and I found out that 4 times with 2, I have 8 hydrogen atom. So I need to have 8 hydrogen atoms, so B is going to become 8, okay. So therefore, okay, I have solved this. So the final answer is going to be 5Fe2 plus 8H plus MnO4 minus is going to give you, okay, Mn2 plus and 4H2O and 5Fe3 plus. If you want to check, you can check as well, okay, by looking at the charges, because charges on the left and the right must be the same. So you can see 5 times 2, so that's going to be positive 10. 8 times 1, so 8. And then I have negative 1, so negative 1. So I have total of plus 17, okay. And I can see over here plus 2, okay. And then charges for water is going to be 0, okay. And then I have plus, okay, 5 times 3, so that's going to be 15. So I'm going to have plus 17 as well. So this one is going to tell us that this is going to be balanced, okay. So we have balanced that, okay. And then let's actually look at the second example. Okay, the second example, we are going to actually use the same method as well, okay. The thing is, okay, I want to show you, okay, because this is going to be involving 1 atom, you can see, yeah, involving 1 atom of Cl. And it is also involving 1 atom of Mn. Later, we will look into example which involve 2 atoms. Yeah, for this one, okay, no issues. Yeah, no issues. I'm not going to select hydrogen ions over here because hydrogen, yeah, is always going to be plus 1. Yeah, so we do not actually include the hydrogen over here. So here, okay, again, similar like what we have done earlier. Okay, I am going to look at the oxidation number. So let's say X, okay, I put the X for Cl over here, and then 3 times negative 2 equals to negative 1, X equals to negative 1, okay, plus 6, and then I'm going to have plus 5. So this is going to be plus 5, and this is going to be similar, X, okay, I just put X, okay, plus 4 times negative 2 is going to be negative 8 equals to negative 1. X equals to negative 1 plus 8, so I'll have plus 7. So I have over here from 5, okay, to become 7. So this is going to be increased by 2 units, okay. And if you look at this Mn, yeah, you can calculate, okay, but we know potassium manganate 7, yeah. So if you calculate, you will get plus 7, yeah. If you do not know how to calculate, you just calculate like normal, yeah. You can refer to my previous video. Now, this is going to be, okay, it is going to change into, okay, I think there is an error over here, okay. Okay, so this one is, okay, the mistake is going to be MnO2, yeah, I put it wrongly. So anyways, yeah, let's continue. So here, okay, this is going to be, if you calculate this, okay, this is X, okay, plus 2 times negative 2 equals to 0. X equals to plus 4, okay, so this is plus 4, and we can see over here from plus 2, 1 atom to become plus 4, okay, so I just put from here to become over here. I am looking from plus 2, okay, to become this is going to be plus 7, okay, to become plus 4, okay. So that is going to be a decrease of 3 units, okay, decrease of 3 units, okay. The Mn is plus 7. Okay, now once I have that, okay, I just need to look at the ratio. Okay, so in this case, the ratio that I'm going to actually use over here is going to be 6 because negative 3 and then 2. So I times this by 3, I make it plus 6. I times this by 2 so that I get minus 6, same ratio. So this number, I told you I'm going to use it as magical number. Yeah. So this is automatically, you just need to put 3, and automatically when you put that as 3, this one must be 3 as well. Okay, the 3Cl must be there. And similarly, okay, for the MnO4 minus, okay, if I put the magic number 2, yeah, so this is going to be 2, okay, automatically this is going to be 2 as well. And okay, the last part that we need to settle is going to be the oxygen. So when we look at this oxygen, okay, we just need to balance the oxygen left and right, okay. And I told you earlier that we do not disturb the magic numbers, okay. So if we don't disturb the magic numbers, okay, you can look at this number 3. So oxygen must be on the left hand side. 3 times 3 is 9. Yeah, this is for oxygen, 9. And then 2 times 4, okay, you have 8, okay, oxygen. This is on my left. And on my right, okay, if I don't disturb the 3 over here, 3 times 4, that's going to be 12 oxygen. And then here, 2 times 2, that's going to be 4 oxygen. So I have, earlier I have 17 over here, and then now I have 16. So left and right must be the same, okay. So on the left, I have 17 oxygen. On the right, I have 16. So this number must be 1, okay. So I must put 1 because why? If I put 1, then only I'm going to have 1 oxygen. So I can actually balance, yeah, 17 and 17. Okay, so if I put 1 over there, hydrogen now, 1 times 2, hydrogen now is going to become 2. So I just need to put 2 there. So I have already balanced this. Okay, so the final answer is 3ClO3 minus plus 2MnO4 minus plus 2H plus to give you 3ClO4 minus plus 2MnO2 plus H2O. In this case, we know that W is going to be 3 and X is going to be 2 and your Y is going to be 2. Yeah, and then your Z is going to be 1. Yeah, so this is going to be the solution for this example. Very simple. Okay, and let's actually move on to the difficult part. Yeah, so this is going to be a special part. We need to give a special consideration for this. Yeah, because okay, now we are going to have a special situation. Now for Cu, okay, to become Cu2 plus, you know the oxidation number of any element is going to be 0. This is going to be follow the chart, so it's going to be, so from 0 to become, okay, from 0 to become plus 2. So from 0 to become plus 2, okay, we know that there is an increase of how many units? There is going to be increase of 2 units, and we no need to worry about that because it's only dealing with 1 atom of copper. Okay, but when we deal with this, okay, if generally we just follow, we just say this is plus 3, yeah, and this one is potassium dichromate, yeah, dichromate 6. If you want to calculate, you can calculate, but generally this is going to be, if you calculate, you will get plus 6 for Cr. But do remember, we are dealing with Cr2. Even though there is no 2 atoms of Cr over here, the moment left or right, we have 2 atoms of Cr. Okay, we are dealing the left and right, the oxidation number is as though going to be for 2 atoms. Yeah, so in this case, not going to be plus 6. Okay, this is, we are for this question, yeah, we are going to be plus 6 times 2. That's going to be plus 12. Yeah, this is how it works. And then for this on the right, it's not going to be plus 3. Okay, even though it's Cr3 plus, yeah, we are going to deal as though we have 2 atoms of Cr, 2 ions of Cr, okay, which is going to be, we are going to put 3 times 2, so plus 6. So therefore, okay, in this case, there is going to be changes from plus 12 to 6, which is going to be gain, okay, in this case, sorry, not gain, this is going to be decrease of 6 units. And the next part that we need to do is to make it as same ratio. So to make it same ratio, I just times by 3. And this one is going to be times by 1. So I have negative 6 and positive 6. So the number that I actually circle over there, we need to be very careful over here. If it is going to be one atom, okay, like for example, copper and copper 2 plus, we don't have any issue. Just put the 3 there, okay, and okay, just put the 3 over there. No issues at all. Now, but okay, for the one that has 2, yeah, we need to be careful. This is the magic number 1, yeah. So if I put, yeah, you need to select where to put this 1, yeah. Do I put it here or do I put it here? Yeah. So I will put it on the left. Yeah, because okay, in this case, if I put it to the right, it doesn't make sense, because if this is 1, okay, then you have 2 CR. Okay, so it doesn't make sense. Yeah, you need to have 2. So this 1, okay, must come over here. If that 1, okay, goes to the CR2072 minus, therefore, we have 2 atoms of CR, yeah, so this one must be automatically 2, yeah, because there is no more CR on the right hand side, okay. So therefore, okay, once we have that, okay, we do have that all these numbers, okay. Once we balance that, it is important, like what I said to you earlier, okay, when we have all these magic numbers, okay, we don't disturb them, yeah. So the next part is to balance the oxygen and the hydrogen. Now, to balance that, okay, do take note, I'm writing it again, okay, do take note, I'm not going to disturb anything anymore, okay. So here, this number 1 is going to be confirmed. So I have 7 atoms of oxygen. So in order to get 7 atoms of oxygen, okay, this E must be 7. And if I put 7 over there, okay, that is going to make my hydrogen on my right hand side to become 14. Okay, so I just need to change this into 14. Yeah, therefore this is done. This is also balanced. Okay, so using this method, okay, we will try some other examples. Okay, and very important, okay, we need to consider 2 atoms, yeah, more than 1 atoms and so on. We need to give a special consideration for it. So here, okay, we have another example. Okay, so first identify which one is oxidized, which one is reduced. Okay, in this case is I and I2, and then sulfur, okay, to become this, yeah. So as usual, I'm not selecting oxygen, I'm not selecting hydrogen, because they are always +1 and -1 in compound and so on. We already learned about this. Okay, so now, okay, we calculate, okay, the oxidation number. Okay, depends on how you want to calculate. I normally separate them into SO4 2 minus. Okay, H2SO4 is SO4 2 minus, yeah. So you are going to actually just use this as X, okay, plus 4 times -2. Oxygen is always -2 in compound, equals to -2. And then, okay, X minus 8 equals to -2. X equals to -2 plus 8. I am going to get +6. Okay, so I have calculated the oxidation number of sulfur is going to be +6. Okay, so I'm just going to write the +6 over there. Okay, +6. Now this one, okay, element is always going to be 0, so I just put 0. This one quite easy, H plus 1, so this one I is -1, and this is element, so oxidation number is going to be 0. Okay, so from here, okay, I'm just going to draw, okay, and then from here to here. Now, for sulfur, there is no issues because 1 atom and 1 atom. Yeah, so therefore, +6 to 0 is -6. Okay, but for iodine, yeah, please take note, okay, on the right, there is 2 atoms. Yeah, so we are going to consider everything left and right to have 2 atoms. Yeah, so in this case, this is 0, no problem. But this is not going to be -1. We are going to consider as 2 atoms because there's number 2 over there at I. So this is going to be no longer is -1. I'm going to consider it -1 times 2, which is -2. So now you have to look at it from -2 to become 0. Yeah, -2 to become 0, there is going to be +2. Okay, and then now we are going to actually get our magic numbers, which is going to be 6, okay, times by 3, I am going to get +6, and then this one times by 1, I'm going to get -6. Yeah, so what we do, this magic number will just come over here, okay, because for sulfur, okay, there is no issue. You just put 1 here, 1, no issue. But be careful whenever involving the 2 atoms and so on. Yeah, in this case, this number 3, we need to decide, okay, whether we want to put it on the left or on the right. Okay, this is very important. Now, if I put this number 3, okay, on the left, okay, if I put number 3 on the left, okay, what happens? Okay, I am going to have, okay, I have to balance, okay, hydrogen, okay, and then I am also going to balance, okay, the iodine. Yeah, let's see whether we can actually put number 3 over there and we try to balance. Yeah, so if I put number 3 over there, okay, 3Hi, I need 3I. How do I get 3I? Probably I just need to put 3 over 2. Yeah, 3 over 2 times I2. Okay, okay, the I2, the 2 and 2 cancel. I have 3 atoms of iodine. Yeah, so I'm thinking of putting 3 over 2 over there. Okay, 3 over 2. And then, okay, for hydrogen now, if I put 3 there, okay, what happens? Okay, we have to check, okay, what is the suitable number of hydrogen. Yeah, so hydrogen, I have, if this is 1, this is 3, so we can see 2 atoms of hydrogen here, and then 3 atoms of hydrogen, so I have 5 atoms of hydrogen. So I need to work for 5 atoms of hydrogen on my right hand side. So how do I get 5 atoms of hydrogen? I put 5 over 2. Yeah, if I put 5 over 2, okay, there is a problem that will arise, yeah, which is going to be hydrogen. I can balance, yeah, H2, so this one I'll get 5, but I cannot balance for oxygen, because oxygen I will get 5 over 2 oxygen, and here the oxygen is going to be 4. Yeah, therefore, okay, we know that we cannot put 3 over here. Yeah, so I just show you first. Yeah, we cannot put 3 over there, so let's try some other way. Yeah, which is the next way is, instead of putting the 3 over here, okay, so I am going to put 3 over here. Yeah, so if I put 3 there, okay, what happens? Okay, you can see 6, okay, I, so you just put 6 over there because you want 6I, and you will have 6 hydrogen, okay, on the left, plus another 2 here. So the hydrogen is 6 plus 2, that's going to be 8. Yeah, so I just need 8 hydrogen, so I just put 4 there. Now the final thing is to check the oxygen. 4 oxygen, and then 4 oxygen is balanced. So therefore, okay, the final answer that I get is going to be H2SO4, okay, plus 6Hi, okay, to give you sulfur, plus 3I2 plus 4H2O. Yeah, so this one we have balanced. Okay, so let's look at the next one. Okay, so the next part is going to be, okay, similar. We are dealing with 2 atoms also. Yeah, so have a look over here. Okay, so sulfur, okay, and then sulfur over here, and then we are going to deal with Br and the Br over here. So for Br, okay, quickly I will just put, okay, this is going to be -1. This is going to be for elements, so it's going to be 0. Okay, and this sulfur, okay, just now I have already calculated. Okay, so I can calculate again. SO4 2 minus, okay, x minus 8 -2, x equals to -2 plus 8. Okay, so I am going to get 6, yeah, plus 6. So this is plus 6, and this is going to be x minus 4. Yeah, 2 times -2 equals to 0, x equals to 4. Okay, so this sulfur is going to be 1, so there is no issue for sulfur. Yes, from plus 6 to become 4, so that's going to be a decrease of 2 units. But for Br, we need to be careful, yeah, because we are dealing with 2 atoms of Br. Okay, so this one 0 is okay, but for this one we need to be careful. This is not going to be -1, okay, because we need to deal as though they are going to be 2. Yeah, so -1 times 2, so -2. So we need to deal from -2 to become 0, so that's going to be a gain of 2 units. So if there is going to be gain of 2 units, you see the same ratio, okay, 1 and then 1. So if it is 1 and 1, okay, all this number, okay, just need to be careful for the Br only. So if the magic number is 1, yeah, so this one is no issue, 1 and 1, okay. But this one, okay, if you are dealing with this, okay, Br, okay, if I put 1, doesn't make sense if I put 1 here. I'll just put 1 here, yeah, Br2. So I have 2 atoms of Br. So I will have to put 2 there, yeah, because on the left, yeah, you must have the 2 Br. Okay, now the final thing that you need to balance is to balance for oxygen or hydrogen. Okay, so you can check over here, okay, the numbers, the magic numbers that you put, you cannot change anymore. There are 4 atoms of oxygen on the left, okay. So I already have 2 atoms, so I just need another 2 atoms. I just put over there, and I will have 4 atoms on the 4 atoms of hydrogen on my right. And if I check on my left, there's also 4 atoms of hydrogen. Okay, therefore, okay, the final balance equation is going to be HBr plus H2SO4 to give you Br2 plus SO2 plus 2H2O. Yeah, so this is balance. Yeah, so let's actually look at another example. Okay, another example. Okay, let's try. Okay, quickly. Yeah, so this one is going to be oxidation number. If you calculate, yeah, this is going to be -3. And this is going to be 0, okay. This is going to be +2, okay. And this is going to be for oxygen, is always going to be -2. So here we are dealing from here, okay, to become this, and from here to become this. So here, okay, -3 to become +2, okay, that's going to be gain of 5 units, yeah, +5. Okay, because negative, this is 0, -3, and then 2, yeah, so 5 units. Okay, so you have 5 units, okay, and then, okay, from 0 to become -2, do remember this is not -2, yeah, don't make that mistake, because, okay, we are dealing with 2 atoms of oxygen, yeah. So if 2 atoms of oxygen, this is 0, okay, fine, yeah. 2 times 0, no issues. But this one, even though 1, we have to look at it left and right as 2 atoms of oxygen. Okay, so 2 atoms of oxygen, don't bother about this oxygen, yeah. So this one, just follow this one, yeah. So if 2 here, and then we have to deal this as though there is going to be 2, so this one must be times 2. So it's going to be -4, okay, from 0 to become -4. This is going to be not -2, that's going to be -4, okay, from 0 to 4. And then what we need to do, we just need to make it the same ratio. So this one, I'm going to times by 4, I'm going to times by 5, okay, so that the ratio is going to be +20 and -20. So if I put 4 there, okay, then without any issues, yeah, you will have this as 4, and okay, because 1 atom, yeah, so this one is also going to be 4, okay, because 4 nitrogen. And you just need to be extra careful on the 5, yeah. So on the 5, you need to decide where do you want to put the 5. Do you want to put the 5 at B, or whether you want to put it at D, yeah. So I will suggest, okay, to put the 5, okay, at, okay, let's try, okay, if you want to put the 5 here, okay, if I put the 5 there, okay, I am going to have 10 oxygen, okay. So how do I get 10 oxygen? 4 oxygen, okay, I just need another 6 oxygen. If I put 6 there, hydrogen is going to be 12, yeah, that's 12, so it's okay, balance already. So trial and error, yeah. So in the end, okay, I put the 5 over here, yeah, 5 over here. And what I have 4 NH3, okay, plus 5 O2 to give me 4 NO plus 6 H2O, so it's balanced, okay. So let's actually have a look at another one. Okay, this is going to be V3 plus, okay, and so on. Okay, I'm going to get the oxidation number now. Okay, so this is +3. Okay, the oxidation number is X minus 2 equals to +2, and then X equals to 4. Okay, so the oxidation number is 4, and V is only 1, so there is no issue. Okay, so I just quickly put +3, okay, to become +4. Okay, so gain of 1 unit. This is going to be 0, and this is going to be -1, yeah, follow the chart. But be careful, okay, we are dealing with 2 atoms of iodine, yeah, so this one no issues, but this one is not going to be -1. We are going to treat it as though going to be 2 atoms or 2 ions of iodine. Yeah, so negative 2. 0 to become negative 2 is going to be minus 2. And then the magic unit, the ratio, yeah, we try to make the same ratio. You times by 2 times by 1. So yeah, we get plus 2 and plus 2 and minus 2. Yeah, and then okay, what we have, yeah, we quite easy. Just put the 2 over there, okay, because this one dealing with one atom of V. Yeah, so we just put 2 there. We just put 2 there, no issues. Yeah, but the one that we put 1, we have to be very careful. Yeah, if I put 1 here, okay, this must be automatically 2. Yeah, because 2i minus. Okay, so cannot be 1. Okay, and then the last part that we balance is we do not disturb the magic numbers. Okay, so we just confirm the oxygen is going to be 2. Yeah, and then in order to get 2 oxygen, yeah, I need to have this as 2. The moment I put 2, then I will have 2 oxygen, and then hydrogen I am going to have 4. Okay, so I need to put 4 there. Yeah, so the final balance equation is this. Okay, H2O to give you 2VO2 plus 2I minus plus 4H plus. Done. Yeah, now let's have a look at the another one. Yeah, now this is going to be our final version. Yeah, as you study when we went through the video and so on. Okay, we have applied certain skills. Yeah, so for this, okay, this is going to be more advanced. Okay, so you can try this. Okay, I will show you. If you want to try, you can pause the video. Yeah, you can try, and then you can come back to this recording and see whether you can balance or not. Okay, but now I'm going to show you, okay, how to balance this. This is what we call as disproportionation reaction. Yeah, because disproportionation reaction is going to be the same element, yeah, is being oxidized and reduced. Yeah, so the best way to solve this is going to be to solve any disproportionation reaction is to separate the Cl and look at the equation separately. I'll just separate the Cl over here. Okay, Cl2. Why? Because I know from Cl2 it will become like this, and this Cl2 is going to become like this. So it's better to separate them first, okay, rather than doing it together. Now, so if you look at this, okay, the oxidation number is 0, yeah, and then the oxidation number is negative 1. Okay, but as we discussed earlier, okay, we are going to actually consider the 2 over here. So we are going to treat this as 2. Yeah, so this is 0 is okay, but this one we have to treat this as 2, so negative 2. Yeah, no, not going to be negative 1. So from 0 to become negative 2 is going to be decreased by 2 units. Okay, and then we can look at this. This is 0. Yeah, and then this is we can find the oxidation number x, okay, plus 3 times negative 2 equals to negative 1. X equals to negative 1 plus 6. Okay, you will have plus 5. Okay, but be careful, yeah, because we are dealing with 2. Yeah, so this one no issues, but this one is not going to be 5. This is going to be 10. Yeah, and we can see from 0 to become 10, there is going to be increase of 10 units. Okay, so that's the difference over there. Now we need to actually make it into this magic number, so I'm going to times this, okay, into 5. Okay, and then this one times by 1. Okay, so both of these we need to be careful over here, because if I put, okay, a 5 over here, okay, if I put the 5 over here, this 5 is going to make this Cl to appear to have 10 atoms of Cl. So forget about this Cl. Yeah, we are dealing with this equation only. So if it is 10, automatically this must be 10 as well. So 10. And then if I times by 1, okay, so if I put 1 here, okay, this, okay, is going to be 2 atoms of Cl. So of course, forget about this Cl. This is going to be 2. Okay, so I need to put 2 there. Yeah, so what I have now, okay, if I rewrite this, okay, this one, if I join them together, 5Cl2 and 1Cl2, it is going to be 6Cl2. So I write down 6Cl2, okay, plus BOH minus, okay, to give me 10Cl minus plus 2ClO3 minus plus EH2O. So the last part that we need to balance is going to be the oxygen and hydrogen. To balance this is going to be involving trial and error. Okay, why? Okay, if you look over here, okay, whatever value that I put over here, okay, let it be 1, 2, and 3 and so on, it will have a different value for the oxygen and hydrogen. Yeah, so like for example, okay, if the E value, okay, if I put 1, okay, what happens to the hydrogen on the left, on the right, and then oxygen on the right? Yeah, so if the E value is 1, okay, what happens? Okay, so your oxygen here 2 times 3 is going to be 6. Okay, and then if this is 1, okay, then there is another 1 more oxygen, so 1, so that's going to be total 7 oxygen. Hydrogen, okay, is going to be, if I have 1, then hydrogen is 2. Now, it is important to notice, okay, if I have, okay, I need to actually put a number over here. Let it be 1, 2, 3, or 4. Whatever number that I put, the number of oxygen, if it is, I put 2 over here, there will be 2 atoms of oxygen, 2 atoms of hydrogen. So the number of oxygen and hydrogen is going to be the same. Yeah. So I will have a difficulty to balance over here. Yeah. So it means the target over here is to get a number, okay, a number that can actually give you the same number of oxygen and hydrogen. That's the trick over here. So the number 1 is wrong. Yeah, we cannot use number 1. Yeah, let's try and error. Yeah, so if E is 2, what will happen if E is 2? Okay, 2 times 2, that's going to be 4. Okay, oxygen, okay, always on this side is going to be 6. Okay, so if I put 2, then 2 oxygen is going to be plus 2, you get 8. So you see 4 and 8, they are not the same. I cannot balance this. So this is also wrong. Okay, I try with 3. Okay, if I try with 3, okay, 3 times 2, 6. Okay, and then oxygen, 3, 6 plus 3 over here, I will get 9. Yeah, not the same. Cannot use 3. Okay, I will keep on doing. Yeah, 4. Okay, if I put 4, hydrogen will become 8. Okay, this is 6 plus. Okay, if I put 4 oxygen, okay, I get 10. Okay, still cannot. Yeah, so this one cannot be 4. If I use 5, okay, so hydrogen is going to become 10. Okay, and then oxygen is 6 times. Yeah, 5, 6 plus 5, so it's 11. 10 and 11 cannot. If I put 6, okay, the hydrogen is going to be 6 times 2, so 12. And the oxygen is 6 plus, okay, 6 oxygen, yeah. So I have 12. Now you have 12 and 12, yeah. So we have achieved something that we want when the E must be, okay, 6. Okay, this is E is going to be 6. So the value of E must be 6. If I put 6, 6 times 2, hydrogen is 12. I want the B to be 12 as well. Yeah, so this one 12. Hydrogen is going to be 12. Oxygen is going to be 12. Why? 6 oxygen. And then 2 times 3, 6. Okay, everything is going to be balanced. So this is already balanced. Yeah, so this is going to be a tough one. But anyways, okay, you should have learned, okay, all the tricks, okay, that you need to remember, okay, for balancing redox reaction, yeah, using oxidation number. Yeah, so if you learn something, yeah, if there is any question that you want to ask me, you can write in the comments. If you like my video and so on, yeah, please don't forget, yeah, to subscribe, yeah, press like, yeah, so that I can actually be more motivated, okay, to help you out and so on. Okay, so see you guys, okay, for the next video. Okay, see you. Bye.